All right, good morning, everybody. Welcome to the AVT Core session. I had a little technical difficulty joining, but it looks like everybody is able to join. For some reason, the device selection took like 10 seconds to just show my devices. So if you're having, I guess saying it out loud is not helpful to anybody. But
Spencer has graciously volunteered to be a note taker, but would like assistance. Is there anyone who is willing to volunteer to help Spencer out? I guess you're using HedgeDoc, right, Spencer?
You can also point out that if no one volunteers to help, that means everyone volunteers to watch and make corrections.
So is anybody willing to help out and take notes? Well, if we don't have a volunteer, I guess we'll have to draft somebody, eh, Jonathan? You have a victim in mind? Harold, would you be willing?
I was going to name Ronnie, but Harold works too.
I guess I can write something.
Yeah.
Okay, thank you. Ronnie, you're welcome to help too. Okay, great.
All right, so we are 6 minutes past the hour. So we probably have more or less a quorum, such as it is. So I guess we can get started. Welcome to the AVTCORE virtual interim. See the information on the slide. I guess you're driving the slides, Bernard?
I can do it, or you can do it.
Yeah.
I'll be happy to do it, but so yeah.
Yeah, why don't you do it, because it's a single unified slide deck. It's probably easier that way. Yep. Here are the virtual meeting tips. Hopefully Mutico's UI has not changed since we wrote this slide, but I think it's all accurate so far. Hopefully you're all familiar with this by now. Next slide. Yep, the note well applies here. Please be aware of, Harold, if you go to the note-taking tool, which is the box of the pencil in the top right, that'll get you to the HedgeDoc. Sorry. So yeah, so the note well applies here. So you're agree to follow IETF processes and policies in regard to IPR and various anti-harassment and general good behavior. Please behave well. Next slide. Not really well. Please remember to behave professionally and treat everyone with dignity, decency, and respect. In general, I think we haven't had a problem with this, but if you disagree, please contact the chairs or the IETF Ombuds team. About this meeting, I'll keep an eye on Zulip. It's actually though okay, that is wrong. The Jabber room is not true anymore. We need to remove that item. It's only Zulip now. Chairs are me and Bernard. I am watching Zulip. Spencer and Harold are note taking. Agenda. Got this thing, the skip payload format. Bernard will talk about his RTP over quick sandbox. Who's presenting for RTP over quick? Is that York or? I guess we'll find out when I get there. So we'll have just more talk about RTP over quick, the spec, and the green metadata proposal. So hopefully it should be a relatively quick meeting, but if anybody has any other business, they can also raise it if they'd like. Next slide. We've got some RFCs published. Our VB9 is still sitting in the misref state. Cryptex and VVC have now entered the RFC editor queue. So that's, they're waiting on the various IANA steps. So that's hopefully will get done relatively quickly. Next slide. Frameworking, we're still waiting on a revision for that. I'm not sure any of the people, any of the authors are here today, but hopefully we'll be able to catch up with them. We'll have a little more talk on skip in the spec, in the discussion. I guess I need to do the write-up for 1783 BIS because we're an author on that. So put that, if you're taking notes, put that on my to-do list. RTP over quick and EVC have been adopted. Next slide. Unless you have anything to say, Bernard. Okay. There's a call for adoption on V3C until October 31st. If you have any opinions on whether we should adopt that, particularly if you're in favor of it and would have interest in doing the work or reviewing the documents or just, implement, I think it should be available for implementers. Please comment so that we can know there's interest. Again, until October 31st. Game state over RTP. There was a call for adoption that was very not terribly enthusiastic, and we thought we needed a plan for planning responses outside the IETF. There's been no further follow-up on that. I don't think any of the proponents of that are here today. So the question to the authors which continue, we might need to follow up with that in London.
Do we have an action item, Jonathan, to follow up somehow on this?
I mean, I spoke to Cullen about it in Philadelphia, and he said he would do something, but he didn't. So maybe we should ping him or sometime before London. Yes, probably we should email probably Cullen and Suhas.
You all have an action item in the meeting notes as of now.
Okay, thank you.
Thank you.
Okay, next slide. And RTP failed for skip. So, Dan, are you presenting?
Yep, I'm here. Thanks, John. All right, next slide. So revision 2 was submitted on August 2nd, shortly after our last meeting regarding comments that were incorporated from the GenArt and ArtArt reviews. The sector comments came in pretty late, actually came in on September 7th. Again, the gist of it, the more comments regarding, the opaque standards and such. I know we've talked about that before and kind of sort of the direction that we were going to go with this draft to treat skip as an opaque standard. So that first part of the comments of the reviewer comments is kind of what we've already talked about before. Didn't really see any action items coming out of that. The other major comment that was in the sector's reviewer was about the security considerations section. The comment was, it may be adequate. Not sure what that means or what we have to change, because I mean, basically that text that's in the security considerations is boilerplate out of RFC 8088. Again, that doesn't, our opinion that skip doesn't add anything or make it any more or less secure or add any additional considerations at this point. So again, we didn't feel that there was any need to change that text as it's written. Certainly open to comments or questions or from the group if they think that we do need to change that text, but from what I understand, it's pretty much boilerplate from most RTP format drafts at this point. So next slide. We finally figured out, I've been trying to do the XML version submission for the last couple of revisions and have been unsuccessful. I mean, I reached out to the IETF tools group. They were able to figure out what the bugs were. I mean, we basically started with a Microsoft Word template. That's what we were using for that. But for whatever reason, the tool, when you go to upload and try to convert it to XML, it would always come back with errors. Again, nothing really, there were only editorial changes, moving stuff around, renaming some sections in there to make it happen. So when there's a new revision to post, we can post it, the XML version. So next slide. So again, I guess it's a matter of, I saw the comments that were added below us in the last bullet about what we need to, what's the formal process for addressing the comments. I thought we replied back to the reviewers with our comments. I guess we didn't do it quite right. I guess I don't know if there's what formal channel it is that we need to do to do
well,
that.
The basic thing here is what we've been finding is, and we've seen this with Cryptex and VVC, is that the authors respond back to the reviewers, but the reviewers then don't say, "Hey, I'm okay with it" or "I'm not okay with it," and
Right.
so you end up in this kind of limbo state. And basically, the ADs increasingly rely upon the reviewers. So the idea of doing this early review is to not get stuck that way. So that's kind of the last step, is to just confirm with them, "Hey, are you okay with this?" And particularly to post it to the list, because then when I do the write-up for publication requests, I can say the following directorates reviewed this thing, the authors responded, and then the reviewers said it was okay, and I just link to them. So it just makes it cleaner, hopefully, to get to through the publication request, and then you won't see all these ISG discusses based on the directorate reviews. Does that make sense?
Yeah, because I mean, like I said, we addressed the Gen Art and Art comments in the last revision, the 02 revision that we posted at the beginning of August.
Did the reviewers say that they were fine with that?
Have not heard anything back. Do I need to reach out to them?
Yeah, that's the problem. Is very
Okay.
often the reviewers don't respond to you, and then the ISG goes, "Hey, it's not. This isn't cleared." So anyway, that's the last little piece to finish up.
So
Okay,
yeah,
well,
I'll probably just reach out to the reviewers to say, "Hey, does this new revision address your comments?"
Right. Okay. Okay, we can do that.
Yeah, once we have those 3 confirmations from the reviewers, then we can go to PubRec, I think, and then you'll get a whole new set of reviews and discussions.
Wonderful. Wonderful. Right. Whoops. Okay. All right. Very good. Thank you. I think that's it.
Thank you.
Yep.
Okay. So I wanted to talk a little bit about kind of experimental program that I pulled together that may be useful in understanding the transport behavior of RTP over QUIC. So why do this? I was just interested in exploring the behavior of RTP over QUIC transport. The goal here was just to visualize it, get to see it, not necessarily to fix things, just to understand what might be an issue. And also, I wanted to try things, do experiments, maybe change a little code, run the experiments again, see what the difference was. And so I didn't want a particularly complex implementation to do that. So I try to do everything with a modular pipeline, which is made possible by an API called Mtu Streams, and also keep the code fairly small and easy to understand, so only in JavaScript. And the other thing was to explore issues that would require not just a sender and a receiver, but a complete system. And that would include things like bugs and unexpected behaviors. There's a bunch of new APIs, and it's not clear that they work as intended. It looks like there might be interactions between codecs and transports. I wanted to try out partial reliability, multiplexing, forwarded behavior, stuff like that. So having a complete system was kind of a useful thing to have. So what can you do with it? Well, I'll show you a little bit, but you can basically vary the encoding parameters. You can choose the codec, the bit rates, the resolutions, and then you turn it on, and you see what basically you can visually compare the local video, which just comes right from your camera, and then we bounce the video off of a server in the cloud, and then you could see the remote video and see the difference between the two. So you could measure the glass-to-glass latency, just get a sense of how jittery the video is, whether their video freezes, stuff like that. So you visually can see what it looks like. And then after you press stop, you get some diagnostics that compute some metrics, RTT stats for the frames, loss, reordering, stuff like that. It's all calculated at the application layer because at the moment, Chrome Web Transport doesn't surface the quick stack metrics. But there's also a graph of RTT versus frame length. We can do additional graphs if people would find that useful. So it was built on next generation web APIs, which are all fresh and new and probably quite buggy. That includes Mtu Streams, web codecs, web transport, and an API called Media Capture Transform. I implemented both the send and receive pipeline in a single worker. That might not have been a great idea for reasons I'll describe. There's some new features that have just come in called bring your own buffer reads that weren't in Chrome Stable, so there's a separate version for Canary. This didn't intend to be a complete implementation. I only tried the stream per frame transport, didn't try the datagrams, didn't do application layer congestion control or GCP or jitter buffering. The idea was to let the experimenter vary the bit rate and then kind of look at what happens. And considering what's missing, it actually works surprisingly well. And that was interesting because I didn't expect that it would work hardly at all without doing all this other stuff, but it does, which is kind of interesting. It's not production quality by any means, but it's useful for experimental purposes. Okay, so there's actually two versions of this. Number one removes the transport, so it does encoding and decoding only. This obviously doesn't help you understand transport behavior, but it's I think of it as a control group. So essentially, you can see what it would look like without any transport. And then in number two, I basically add the network transport to the sending and receiving pipelines. And obviously, you need to serialize and deserialize as well. And what's useful is you can compare the behavior with transport to that without it. It may help isolate some of the things you're seeing. As I mentioned, there are two versions. There's one in Chrome Stable and another one in Chrome Canary. And there's a GitHub repo if you want to look at the code. It's up there as well. And the code for number one is also up in a GitHub repo. Okay, so here are some of the things you can play with. You can select the average target bit rate, which is, I guess, supposed to be an average, including the keyframe and the p-frames. In practice, the actual bandwidth consumption is typically lower. And I guess that depends on your keyframe interval, which is the number of frames between each keyframe. The default is 300, so essentially at 30 frames a second, that would be a keyframe every 10 seconds. The codecs supported are VP8, VP9, H.264, or AV1. I did note some strange behavior of VP9. I think that's probably a bug in web codecs. If you select real time, you get this very large frame size, even for p-frames, like 10 kilobyte p-frames, which doesn't make sense. If you select quality, that changes, so I think there's a bug there. AV1 is pretty solid on macOS, not so solid on Windows, so there may be some issues there. currently Chrome only supports H.265 decode, so you can't really use it in this application. You can choose whether you want hardware acceleration or software. It doesn't seem that hardware acceleration is very widely supported, so the default is no preference, which will probably end up being software most of the time. There's this latency goal, which can be quality, which produces smaller frame size, but only takes marginally longer than real time. I'll talk about that. That's a little, the behavior there isn't quite what you'd expect. You can actually support SVC temporal scalability. The default is 3 temporal layers, and that's useful for reasons I'll describe, because you can do partial reliability. And then you can choose your resolution. So you can have a small resolution, or you can choose as high a resolution as your camera will support. Some of the newer cameras support full HD, and that is sometimes useful, particularly for looking at higher bit rates. Okay, so here are some observations after playing with this for a while, and you can play with it too and see what you think. The video quality is highly dependent on the device and the camera. Good quality seems to be possible, particularly if you get up to about 1 megabit and you're using a desktop or a high quality notebook, you have a good camera. I've been able to generate full HD video with a talking head and a target bit rate of 1 megabit, and it looks pretty good. The actual bit rate is more like 700 kilobits, something like that. But if you choose a complex codec like AV1 and a higher resolution, you will see high CPU utilization. And in particular, your encode worker will probably peg at about 100% CPU a good portion of the time. And I think there are some effects of that, which I'll discuss in a minute. The other thing is that the combination of quick and temporal scalability gives you pretty good resilience properties. Quick is good at retransmitting, getting stuff to the other side. And if you do temporal scalability, then a large proportion of all the frames you send are discardable. So you don't, if they take longer than you think, you can actually send a reset and it'll be fine. The decoder will keep on chugging. So that is actually, it looks like a kind of nice combination for resilience there. And overall, in the experiments I've done, I've seen very, very low loss. I've also been on pretty good networks, so that's part of it. But overall, this seems to do a good job of delivering frames. So latency, this is where there were more issues. I observed, particularly with the higher resolutions, I observed glass-to-glass latency considerably higher than the measured frame RTT. We'll get into that in a bit. But the P frames were typically small, and we'll talk about that. But we're talking about a few thousand bytes, so a couple of packets for the P frames. And those come in at very low RTT. They look like they're coming in many cases, clustered around RTT min. But the iframes are a lot larger. I've seen iframes as large as 200 kilobytes. And they exhibit some issues. Often the frame RTTs are multiple times higher than the P frames, although interestingly, not always. We'll talk about that. The effect is most pronounced with the high GOP sizes. As I said, I used a default of 300. And in that case, you only get a few iframes per experiment. And I think I have an idea why this might be that way. Also, you see the effect of this higher frame RTT and the glass-to-glass latency, even under conditions of low bandwidth utilization. So I've been running these experiments on a gigabit network, only consuming 700 kilobits with very, very low loss, and you still see this high glass-to-glass latency and some of the large frame latencies on the iframes. So we'll talk a little bit about why that might be. Okay, so here's an example. Running AV1 with a full HD camera. Target bit rate was 1 megabit, the GOP was 300, and the actual bandwidth consumption was around 700 kilobits. What you see here in the smaller frames, these are probably mostly P frames, or almost all P frames. They're very tightly clustered around 100 millisecond frame RTTs. So this is probably very close to RTT min. And what you can see here is you can draw a line with the of the RTT versus frame length, and at least on the lower end of the length scale, it's pretty close to that minimum round trip transit time. But on the right, you'll see there's some frames of roughly 25 kilobytes, and then another one maybe 37, something like that. These are iframes. There's two of those because I ran the experiment roughly around 12 seconds, and so you had two keyframes. And there you'll see that there's the RTT above and beyond the minimum round trip transit time. The frame RTT looks like about 200 milliseconds larger on one and maybe 100 and something on the other one. So the question is, why are we seeing this? What's going on here? I'm not sure I can have the complete answer, but I'll give you what I think the answer might be. So basically what's happening here, because the GOP size is so large, is that the P frames are all pretty small, right? A couple of packets. So they don't really push the congestion window up. So essentially we're in an application limited situation. And as a result of that, you don't really get a good bandwidth estimate. So what happens is you then send this iframe, which is dozens of packets, and it's likely that your congestion window is too small to send them all in one RTT. So you get multiple RTTs. So that's why you see the frame RTT being multiples of this RTT min that you'd see. The other thing is that because you don't really have a particularly good bandwidth estimate, the application isn't getting particularly good feedback, and so it can't adjust the iframe size or quality. So, for example, it could change the average target bit rate once every GOP, or potentially it could use Web Codex is about to implement per frame QP, so it could adjust the actually either the iframe or the P frame on a per frame basis in response to perceived congestion. But if the bandwidth estimate isn't very good, that's not easy to do. So one potential way to fix this is through what we call probing, which was implemented in WebRTC, where essentially you try to fill up the pipe, even if the P frame size is very low, and so you're not filling the congestion window. You try to fill it with something else, like RTX probes or FEC or something like that, to kind of push up the congestion window, so that by the time you get a better bandwidth estimate, and by the time you send the iframe, you don't have all these multiple RTTs, and can send it in one RTT. So here's some of the evidence why I think this is the cause, although need to do some investigation to confirm. One is that playing with a latency preference produces some odd results. That is, when you set the latency preference to quality, you reduce the frame size quite a bit because the encoder spends more time on it, and you reduce it, and you actually see that kind of excess RTT, frame RTT, go down. So the frame size gets smaller. You're not using as many round trips to send the iframe, and you see it come closer to the transmission line. Also, after you send that maybe second iframe, subsequent iframes show a lower frame RTT. So the congestion window maybe got pushed up a little bit. It finally grew because you actually filled the pipe. And so if your GOP sizes are smaller, you actually get a tighter RTT scatter, which is kind of interesting. Not necessarily a great idea because it uses a lot more bandwidth, but it's just an experiment that shows that this might be the cause for what we're seeing here. Okay. Another effect that I noticed was the effect of CPU utilization. As I said, I put all of the encode, decode, and transport all on one worker thread. It probably wasn't a great idea because with the AV1 and higher resolutions, you're pretty much taking out that core or thread with 100% CPU utilization, and that may be the cause of the high glass-to-glass latency. Not entirely sure. So one way to try to figure out if this is true is to support more threads. So for example, maybe it could separate the sender and receiver pipeline onto a separate thread, and see if that lowers the less latency. Okay, so also in the process of playing with this, came up with some issues that I filed, and I think Matthias will talk about some of those. But here are some of the things that came up in the process of playing with this stuff. One was that, as I mentioned, partial reliability seemed like a good idea because we had support of SVC. And so for the discardable frames, we didn't have to wait forever for them to retransmit. Could potentially just send a reset after the timer expires. But one of the interesting things is that partial reliability requires support for reset frames in any forwarders that you have. And also, when you do this on the receiver, you don't necessarily know when you've gotten the complete frame. So in theory, at least, the quick spec says when you send a reset, the sender should stop retransmitting when it gets that reset. And also on the receiver, it's a should that it should basically use the reset stream as a signal, prioritize it when it comes in, not queue it up and wait till you get to the reset. So potentially you may not get the entire frame, and so having a length field is a potentially useful thing. I think Matthias will talk about that. The other thing is because of this differential reliability, you may want to send some portions of the stream with datagrams like the P frames, or maybe you want to send the I frame with reliably over a reliable stream and so forth. So that's another issue I think Matthias will talk about. Another thing that came up was multiplexing of data and media. Basically, I wanted to make this as simple as possible and have a single quick connection. So what I did is I'm actually sending the signaling over the same quick transport, quick connection as the media. So that seems like a pretty useful thing to do. And also, I'm not doing this, but you might want to communicate state or device input, again, over the same quick connection. So it's useful to be able to multiplex the data and media. There's an issue 31 that talks about some of this. I think Matthias will talk about that as well. And then there's some issues with RTP topologies. I was just doing kind of an echo server, which is kind of like an RTP translator, but that got me thinking about a few things that a translator needs to do, which is different from what we think of RTP translators as doing. So particularly if you were to translate between RTP over QUIC and RTP over UDP, you'd actually need codec-specific knowledge in the translator to do the packetization, because you're basically dumping a whole frame into this potentially into this quick stream, and then the translator needs to figure out how to packetize it. And that could be a little bit awkward, because if you think of the translator, we don't usually think of them as having knowledge of the packetization of all these different codecs. So that's a little weird. The other thing is if you're using S-frame for end-to-end encryption, it would how does this translator packetize this opaque blob, right, of S-frame stuff? Even if it did have codec specific knowledge, it actually doesn't have the encryption keys. So how would it do that? The only option it would have would be generic packetization, and we've talked about that. So those are some questions. I think Matthias may talk about some of those in the next presentation. A little bit more about partial reliability. Basically, the idea was to take advantage of SVC to not have to retransmit the discardable frames endlessly. So we set a timer for those, which could be fairly low. As you saw in the graph, the P frames were fairly tightly clustered around RTT min. So basically, if something has a much larger RTT, you basically can send a reset and forget about it. But as I mentioned, it does it's helpful to have a length field, because then you can figure out if you got it. The other thing to note is that, and I think you've seen this on the graphs, the iframes can be pretty large. I've seen them as large as 200 kilobytes, so a 16-bit field isn't necessarily large enough to cover that. So that's something to think about. The other thing is, in my server implementation, I didn't found some bugs. I wasn't forwarding the reset frames. I was also doing store and forward, which adds a little bit to the latency. So you have some things to think about in a forward or a translate. It should probably just forward the reset streams and the fins and stuff like that. Doesn't need to get the entire frame before forwarding it on. Should probably just do cut through would make a lot more sense. Okay, I mentioned a little bit about the data and media. There's multiple uses for it. And in this particular experiment, I didn't need multiple APNs, just use a single well-transport ALPN and you can send whatever you want over it. And that's kind of how WebRTC works. There's a single ALPN for DTLS for both media and data. But it does bring up the question of what do you use to distinguish the media from the data? I did some kind of a dirty hack to do it, but we probably should talk about how that would work. Okay, are there any questions?
Spencer.
Yeah, Bernard, thank you for doing this work a lot. One question I had, and this is going to be kind of a your take on the state of the universe question. Do you have a sense that we're going to need to rely on quick datagrams to do RTP over quick well?
Yeah, that's a really great question, Spencer. That was one of the questions I had going into this, and it's why I focused on the frame per stream instead. The good news is, as for the P frames you saw, they're really clustered around RTT min. So at least for those, it doesn't seem like you need datagrams, right? You're getting this. Quick does a really good job of sensing the bandwidth and so forth. So, I guess my answer to that, Spencer, would be dependent on whether I can get that glass-to-glass latency down. I suspect the glass-to-glass latency issues have nothing whatsoever to do with datagrams versus streams. I think it may be due to the CPU pegging that I'm seeing, maybe some other things. And I have been, as I improve the code, the latency, overall latency comes down quite a bit. So I want to take a rain check on that, but I'm not really. I think there's some evidence that the frame per stream might be sufficient for a lot of applications. But I want to get the glass-to-glass latency down before I would, be able to be confident in that assessment. Does that make sense?
It does to me.
Yeah, so I'm hoping by IETF 115 I'll have made some progress, like particularly on the multi-threading issue, see if that CPU problem is what's causing that latency to go up.
Shuai, are you in the queue to speak? You're asking to share your screen, but that might have been a mistake. Otherwise, Peter?
Can you hear me okay?
Yeah.
I guess I can unmute my video. That work? All right. I was just going to mention that in my previous experimentation with using streams, that it worked fine except for the congestion control issues. And I think those would be the same between datagrams and streams. So I don't think it's a question of streams versus datagrams. It's more of a question of how the congestion control worked for both.
Yeah, I mean, if the hypothesis we had here is correct, it wouldn't matter if you dumped the iframe in a single stream or if you dumped it in a datagram, right? I guess the only difference would be, yeah, the quick would basically, congestion control would do the same thing more or less, right, Peter? Yeah, so you'd see more or less the same kind of extended. You'd see essentially multiple RTTs to get the whole thing there anyway, because the congestion window wouldn't be open enough, I guess. Does that make sense?
Right. And then, yeah, I think that's what I was trying to say. Yeah.
I'm next in the queue as an individual, just asking. I'm wondering if you had any thoughts. I guess this might be then more input to either the Web Transport Working Group or the W3C Web Transport API. Whether the current what would be useful. Do you have enough information to do meaningful debugging and analysis of what's going on, or do you need more information out of the browsers?
Yeah, that's a great question. I will say that debugging this stuff has not been fun because like you use your traditional web tools like the performance toolbar, and it doesn't show any info on web transport. So it's not like you get any info on the quick stack. It's not like you have WebRTC internals. There's like nothing like that. So basically, I'm having to instrument everything myself and look at packet traces. So actually, that is a great question. And I will say that the more I work on this, the more I appreciate WebRTC, where the browser does everything for you. Like in this kind of work, you have to do your own threading. Like you have to deal with that. And WebRTC, basically, it handles the threading of encoding and decoding and all that. So a lot more stuff to think about here.
Cool. Sergio?
Hi, hello. First of all, thank you, Bernard, for all the work that you have put on this. I think that it is great to see this kind of real life experience. I have a question that I'm not sure if it is for you or for the next presenter, but I will do it anyway. I assume that when you talk about sending one frame per stream, it's like you are considering like the MTU to be infinite, and you just send a
Yes.
single an RTP packet with the whole frame as payload.
Yes.
Would it make sense to use using like RFC 4571 to send to still packetize it the frame in multiple RTP packets and send all together in the same quick stream? So why? First, because they will allow us to have like a gateway that just have received RTP over web transport in one side with this per stream and with one frame per stream, but it will still have the individual RTP packets inside the stream, so it can forward them to by normal WebRTC. And second, would this solve the issue that you have about knowing in the receiver side when you have received the latest packet or not?
Yeah, I think any length field does help with that, whether it's 4571 or something else. I think it's a good question, Sergio, whether you might want to packetize it anyway. I don't have enough information. One of the hypotheses I had before this one that I presented here was that it could have been a pacing issue, like dumping these huge iframes in and having them spewed into the network might not have been such a great idea. The information I've seen on the congestion windows suggests that that's not happening. I think maybe we should leave that discussion of the length field. I think Matthias will have a presentation on that, so we can pick that up there. But anyway, I think discussion of the length field is a useful thing to talk about.
Okay, thank you.
Harold?
Hi, all, this John. And it seems to me that the congestion control issue is strongly linked to the differing models of congestion control that we have with real-time media and with the window, because the thing you hit is that you don't get all the iframe out within the congestion window. Well, if you have a bandwidth limited congestion control, where you try to estimate the bandwidth, it's rather easy to do a pacer so that the pieces of the iframe can go out at a reasonable pace. So it does seem to indicate that the model of the congestion window and the sending of frames that are larger than the congestion window don't quite go together.
Yes, that was my conclusion, Harold. I thought it might have been pacing, but then I checked the bandwidth and I checked some of the traces, and it didn't seem to indicate that pacing was the problem. At least in this particular the experiments I ran on very, very good networks.
All right. I
Okay,
don't see anyone
I
else in the
think-
queue.
Oh, okay.
Yeah, I think we're saying the same thing. So, I guess, Matthew, so you're presenting the next one? Yes, go ahead.
Yes, I am.
Great.
Yeah, thank you, Bernard. That was very interesting. So thanks for building this and bringing the issues back to the spec. I will talk about some of them later, but let's start with a short overview of what changed since last time. We added a short paragraph about clarifying the usage of streams, which now says that we're only using unidirectional streams. And then we added a paragraph that said that we have to immediately close streams after sending one packet, which is important to make sure that the receiver can identify the end of a packet, which is useful if we don't have a length packet, but we will get to that later again. Then we clarified the flow identifier usage for datagram retransmissions, which was an open issue last time because it wasn't clear where or which flow IDs I should use. That depends on which RTP stream they are sent in, which is now more clearer in the spec, but we will also get to flow identifiers again later. I added a short paragraph about exposing the bandwidth estimation to the API considerations, and I removed a couple of obsolete editor notes from the document. And currently there are a few open pull requests. One is for topology, which Bernard already mentioned. And then there's one for stream concurrency and one for expressing the congestion control requirements instead of specifying fixed congestion control algorithms. Then, yeah, thanks. So I would like to talk about 4 issues today, and 2 of them are kind of linked, which is this one and the next one. Bernard already mentioned ALPN usage, and he used one ALPN, if I understood correctly, for sending data and RTP in the same quick connection. We currently define the ALPN token RTP MUX quick in the document, which we thought could indicate that we can multiplex RTP and other protocols over the same quick connection. The problem with this may be that if we have other protocols defining a map into quick, they also have to define some ALPN token, which would be incompatible to ours. And the second problem, which came up with that, is the issue of multiplexing, which will be the next slide. But let me finish this one first before we maybe discuss both of them. If we do multiplexing in or RTP over RTP MUX quick as multiplexing multiple different protocols, we don't really know how is the multiplexing actually going to work between the different protocols. So our proposal for now is the one on the left side here in the green box, to define RTP quick instead of RTP MUX quick, and then have future documents to specify multiple new ALPNs for different multiplexings between different protocols, for example, RTP, RTCP, and some other data protocol. And I think that approach would be similar to what was done for WebRTC, which defined a new LPN for WebRTC in an extra document. The alternative to this one would be to have or to continue using RTP MUX quick, but that would be or that would still leave the question of how to actually multiplex different protocols open, which would be on the next slide. Bernard, is a question directly to this one, or could we continue using or seeing the multiplexing slide first and then discuss it together? Then yeah, let's talk about this one first, and then we can have a discussion about both together, maybe Bernard. So the multiplexing issue is that we initially defined a flow identifier for multiplexing RTP, RTCP, and whatever else. By appending the flow identifier to each packet we send and having the receiver identify which stream it is sent on by passing the flow identifier first and then continue passing this packet on. If we define RTP quick, as I said or proposed on the slide before, we only have to use RTP, RTCP in this quick connection, and we only have the issue of multiplexing RTP and RTCP, and we don't have to think about any other protocols in the same quick connection. There is, however, still the question if we still need a flow identifier. We can do RTP, RTCP multiplexing by RFC 5761, and we can send multiple types of media in a single RTP session, but I think there's no equivalent to sending multiple different RTP sessions as we could do it, for example, in using different different UDP ports, because we only have this one quick connection. So if we still want to use multiple RTP sessions in the same quick connection, we still need something like a flow identifier to identify them. If we do RTP MUX quick, then as I said before, we still have the issue of multiplexing RTP and RTCP with other protocols. And that could, for example, be done by the flow identifier, but that flow identifier may not be compatible with the other protocol, whichever that is. And an alternative to that could be to use RFC 7983 bis. But the problem with that, I think, is that we don't necessarily want to multiplex the protocols which are specified in that RFC, because, for example, DTLS doesn't make much sense to put on top of quick next to RTP if we can just send data channels protocols, for example, next to RTP instead, without using DTLS. So yeah, Bernard, do you have any thoughts about that?
Yeah, so I think there's a couple of questions I have. I don't know that I have solutions, but one is that if you start requiring multiple APNs, I think that's going to end up requiring multiple quick connections. I mean, they could go over the same port, you know, with different connection IDs, but I'm not sure that's I think that's probably, you probably won't want that. I know that trying to stuff them in the same connection does raise issues, maybe of priority or something like that. But the kind of things that I'm thinking of that you would multiplex in the data are probably relatively small bandwidth. I mean, I guess you could do a file transfer, which could be a problem, but in most of the time, it would be something like the negotiation or some small updates, in which case it would be nice to be able to send them over the entire quick connection. So that's why I kind of like RTP MUX quick. Of course, you then raise the question of, great, you can MUX them, but how? That probably deserves more discussion. I would agree with it. It doesn't make a lot of sense to multiplex DTLS and support that within a single quick connection. But so we probably need to think about that a little more. With respect to the flow ID, I do have a question about the usage model, and we can talk about it more. But the reason we have the flow ID in web transport is because the idea was to support multiple browser tabs. And so we use the flow ID to separate the browser tabs. I'm not sure necessarily that would be the model in RTP over quick, although I could be wrong. So it might be worthwhile to kind of articulate what the use cases are there, and whether we might just say, hey, everything that's on this quick connection is a single session, and leave it at that.
Okay, thanks. I also think it makes sense to have something like RTP MUX quick for later. For example, for using RTP and data channels, or something that does something like data channels in quick in the same connection for RTP and that data channel protocol. But as long as we don't have this other protocol, I think we should move on with this document and define RTP quick first, and then allow future documents to define RTP MUX quick, which can do RTP and another data channel protocol on top of quick in the same connection. Does that make sense?
Yeah, I personally think that you kind of know what some of those other things are. It would be like negotiation and some small updates, but so I think it might be confusing to have two different ALPNs for the same thing. That's just my opinion, though. We can talk about that.
Okay. Then Peter.
So the question of multiplexing is very similar to web transport, and so the solution we came up with there, I think, would make sense for sending media as well. But I think what you could do in this document is define how to send RTP over quick-like connections that have streams and datagrams. And then if somebody wants to run that over web transport, they can. If someone wants to run that over a single quick connection, they can. And in the context of web transport, you kind of get the multiplexing for free because web transport already has its multiplexing mechanism built in. And if you want to do it in the sort of one RTP session per quick connection, you can. But if you define the whole document in terms of some substrate below that has datagrams and frames, then I think it would be more flexible for different situations. And in particular, being able to use it over web transport with its built-in multiplexing.
So that would mean that we have some kind of abstraction from Quick, and we say in this document we just have RTP over something that behaves like this or like web transport. Do you understand correctly?
Yes, exactly. So that the definitions of everything else in here would apply to both a scenario where you want to use one RTP session per Quick or one RTP session per web transport session, or something else someone else comes up with in the future. But it could, the same definitions of things could be used in all of those scenarios.
Yeah, I see. Thanks. Jonathan?
Jonathan Max. I think sort of, partially, largely agreeing there. I think Bernard's comment makes sense in the context of web transport, where you have your own custom signaling mechanism. I think if you're talking about raw quick, or it would have whatever you're multiplexing with, it have to be a defined protocol. I don't think we're anywhere near ready for anything like that yet. I agree that having something, making this make sense for both raw quick and web transport makes sense, whether you want to describe that as an abstraction layer or specifically mapping to both. I mean, it's more or less the same thing. It's just how you describe it. But I think I agree that writing this in a way that makes sense for both raw quick and web transport would be sensible.
So one question I have about the making it work for both is then we have the multiplexing from web transport, but we still need some kind of multiplexing for the raw quick version, right?
Sorry, wrong button. Maybe if you have it defined for web transport, then we don't need multiplexing for RTP itself. If we don't know what we're actually multiplexing it with, that we're defining, as opposed to you want to multiplex it with something, which is what web transport does for you.
Okay.
So something, if you have something custom and proprietary, web transport is obviously well designed for that. Whereas for I feel like if we need to be demux with at the RTP level, if you're actually talking, box to box that's directly doing RTP without, if you're doing custom stuff, then you can do custom stuff for the demultiplexing. Whereas I think you need to define it at the protocol level if we're actually defining the protocol we're demuxing with, which I don't think we're anywhere near ready for.
Jonathan, this is Spencer. Could you take a look at the notes and see if I'm getting anything like what you just said?
I'll take a look at it.
Thank you.
Yeah, I think I have to think about this a bit more about how this kind of abstraction, I think of it as an abstraction would work for RTP over raw quick then, I think. Yeah, maybe we can move on first here. Jörg?
Now, okay. Thanks. I had multiple small points. Briefly back to Bernard's point about sending other small signaling messages back and forth. I'd like to understand what kind of signaling between whom. All kinds of renegotiation would usually follow the signaling path that would be used to set up the subsequent quick connection for RTP or TCP if you had some of the signaling path, then that's it. That connection would exist up front and might actually go between different entities. So I'm not completely clear on what that would be used for exactly. The other point I wanted to make is that we had a bunch of comments early on about Arpn usage and what the exact semantics would be. And one of the decisions that we took was trying to keep it dead simple and say, okay, we need to understand how all of this works for plain RTP, RTCP only, so that we don't get into prioritization issues or different types of congestion controls for reliable and unreliable media and so forth. So there are a whole bunch of questions to be answered and understood if we want to do this broader perspective. And that might easily take us quite a bit of time to sort this out. So I would still be kind of in favor of trying to get a very well-defined solution for a very well-defined problem space, rather than opening this up very broadly at the beginning, which might make us go around in circles a few times. I do see the value in making this, for example, usable in a broader abstraction, but I would feel more comfortable if I understood all the implications before trying to design a solution. So this was why I'd be happy to rather focus on a narrow solution space right now, maybe exploring the others in parallel, but not trying to board the ocean right away.
Benno?
I don't think you necessarily have to take on boiling the ocean. In other words, you could say, hey, we're doing this RTP Mux Quick thing. We recognize that this doesn't work for all apps. Like if you want to send a file transfer, it might not work well, but this is something you can use for these kind of small data exchanges, which is much of what we see with WebRTC, by the way. I mean, there are some people who use the data channel to send media along with data, but I'd say most of the RTC data channel usage is these kind of small updates, like game streaming going back the other way, stuff like that. Typically, you don't do a lot of muxing of data and media. So I don't think you necessarily have to solve all those problems. You can say, hey, this is what we do. It doesn't solve all problems. And then, if something comes along later, my concern would be we may or may not have this prioritization solution necessarily. It could take years. And meanwhile, if people don't have the ability to multiplex data, they'll just invent their own thing or just do multiple quick connections, and the whole thing will just rapidly degrade. So I just say, just try to do something simple, state the limitations, and be done with it, and not try to solve every problem. That would be my take.
So for that, we could, for example, define RTP Mux Quick and then just say RTP and RTCP is allowed, and you, if you want, can also send other protocols, but you have to figure out your own multiplexing.
Well, you probably should open an issue and figure out if the group wants to specify something now. You could say to define your own muxing, and maybe something like 7983 BIS is the way to do it, or maybe you want to do the flow ID. I guess I would leave that discussion open. I don't think you necessarily have to solve it here. You could let the app do it, but if there's something you think is relatively straightforward to do, you could do it in this document or not.
Yeah. So the issue is the NEM24 here. So if there are any more comments after the meeting, then I would appreciate if everyone puts it there. Spencer?
Yeah, thank you. So this is probably for Bernard, but I'm a little confused about whether you're talking about having your application that is still doing the same ALPN, but the effect behaves differently in the future, versus how big a pain it's going to be to do a new ALPN. If we do RTP quick and then do RTP mux quick. Is that, can you, if you need to explain this to me over a beer sometime, that's a fine answer too.
Yeah, it's not all that complicated. As an example, when I was writing the little sandbox thing, I sent the configuration of the codec along with the media. So in other words, web codecs, when you configure the encoder, it spits out a string that you can dump into the decoder to configure it. And so it's kind of like a poor man's offer answer. You can just say, here's what I'm sending, just send it along in the first kind of pseudo frame. The decoder consumes it, configures itself, and then you just send the media. So it just, and also I thought, hey, and if this were a conferencing server, and so that the endpoint of the media and the signaling was the same thing, it'd be pretty useful to do your offer answer within the same quick connection, because then you know what, essentially it's a built-in way of associating these things with each other, and knowing that this is the signaling for this set of media streams, as opposed to starting to open multiple quick connections. One of the big discussions we had in web transport about session IDs was all about trying to collapse the number of total quick connections we had so that they didn't explode. And people were saying for deployments, this was actually a big issue. You don't want to have a connection explosion because it limits your scalability. So anyway, those were some of the things that came to mind, Spencer. Be happy to talk more about it. But
Beer, yeah, thank you for that. Also, Beer, thank you.
Yeah, I'm just sort of thinking, off the top of my head here, maybe this is a bad idea, it won't work, but it occurs to me we could just say, if you want multiplexing, well, web transport has defined a perfectly good demultiplexing scheme. You don't have to be a browser to use web transport. Just use that. And that might be worth something thinking about. I'm not saying just something I just thought about just now, so I'm not, maybe there's some fatal flaw with this, but it might be something worth thinking about.
Okay, thanks. Then I think I would suggest that we move on to the other two issues first and have discussion in the issue of this one here. Yeah, Bernard also brought this one up in the presentation earlier, length field and quick streams. So far, we only added the sentence I mentioned earlier that quick streams have to be closed after a packet was finished to identify the packet boundaries as the receiver. But it might also be helpful to have a length field for buffer allocation or for identifying incomplete frames in quick earlier. So there's a suggestion to add the length field. And then if we add a length field, there's the question of what kind of length field. Bernard mentioned that 16-bit fields from RFC 4571 may not be enough because the payload may be longer. Alternatives are using units of 4 octets or a longer field or quick variable length integer, as we have been using for something else, I think, provided. Yeah. Any opinions on this one? Or are there any cons to adding a length field, maybe more specifically? Spencer?
I have lowered my hand when I turned my mic off, but I didn't. I'm sorry.
Oh, no problem. Jonathan?
Jonathan, are you muted?
Yes, I am. Thank you. Sorry about that. I always get confused with raising the hand versus the turning my mic on. Yeah. So I guess my question here is, in terms of the length field. I mean, I guess the question is about APIs for the incomplete frames question. I guess I'm necessarily asking about web transport, but I guess that might be relevant otherwise. Do they tell you the difference between a stream that was reset and truncated versus a stream that was received, up to its fin. Because if they don't, you could obviously identify. I mean, if they do, you could identify incomplete frames that way. I mean, buffer allocation obviously is still potentially an issue. Then the downside here obviously is just the extra bytes you're spending. I don't think there's particularly any other, downside as such, other than just architecturally, you have the streams doing the framing, so why do you need the extra framing here? My inclination would be to variable length integer just so as not to spend the bytes, but still give us the flexibility to go very large. I think even the 256K of the 4 octets would be potentially limiting as you get to very high bit rates if you're doing really doing a frame per but yeah, I guess are those APIs, I guess, and Bernard as the one who's been working this and raised the issue, does it tell you that difference? Because that's obviously how you could tell whether you've got a truncated frame or not.
Yeah. So in the Web Transport API, Jonathan, you're supposed to get an error if you receive a reset versus what they call a done indication if you receive a fin. So at least in theory, you should be able to tell the difference. However, what I found is sometimes the reset doesn't get forwarded. Like in my dumb server implementation, it didn't forward the reset, so I actually didn't get the done, and I didn't get the reset. So I raised the question about whether the reset was always reliable, because what it's supposed to do is turn off retransmission. And there's actually a draft that's been submitted to Quick for kind of a reliable reset. So that's been a question that's been raised about whether it'll always come through. So anyway,
Okay.
So some take it as a signal and push it up, even before processing the other frames. And some.
Yeah, the important question is not did you get the reset? It's did you get all the entire frame or not? Right. So
right.
If you got all the frame and then it was reset, then whatever, you got it.
Also, for the reset, I think you get a length field in the reset, so you know how much data was consumed, but it's not the same as the total size of the frame, which would have been sent if the stream finished normally. So you might not get the value you need. Harald?
I was kind of reminded of HTTP 0.9 to HTTP 1.1. where the length field was introduced. And length fields are sometimes not the best way to delimit things. They mean, among other things, that it's impossible to change your mind after you start sending. So if you want to send something, you should be able to send it out and then know whether it's completely received or not, which might be done with a trailing non-fakeable signal or checksums or whatever. But length fields sent out as a header are not the only possible solution, and perhaps not the optimal solution. We have burned ourselves before on that one. But if we have a length field, I would definitely go for a variable length integer.
Okay, thanks. That's, I think, good to keep in mind. I don't know so much about HTTP 0.9 to 1.1, what happened there, but yeah, I think we should keep that in mind, maybe. Length field might still be helpful to have buffer allocation. Peter?
About the fin, isn't the fin reliable? So you could just have the rule, if you receive the fin, you know you received the whole thing. And if you haven't yet received the fin, then you know there's more still to come. So I think the fin operates as the, the trailer that lets you know you're done. That said, if we do decide to do length prefixing, I agree, it should be a quick variable length integer.
Peter, sorry, just to interject. Is that then reliably also relayed in the in the web transport APIs?
Yes, so I believe so, because the readable stream will close. And you'll know when the readable stream that represents a quick stream finishes and it's closed properly, as opposed to being improperly closed.
Is that even true, Peter, if you send a reset after the fin?
I'm not sure about that, but I guess if the other side reset instead of closing it normally, then it doesn't matter what you do with it on the receiver end. It's kind of like undefined behavior.
You'll get one or the other, basically, depending on what happened. But,
right, but if they're unless what you're suggesting, Bernard, is someone does a reset after, say, 3 seconds of writing things in order to have partial reliability, and then you get that ahead. But then it's like, okay.
Yeah, like in the app, I'm setting the timer. I don't really know whether I whether I did the abort before I finished everything or not, right? I have no visibility. So.
But if the reset gets there first, I mean, that means your data took a long time to get there, assuming you're setting a timeout that's.
Yeah, we probably should look at the quick spec about what's supposed to happen. But I read it and I was still confused as to what the behavior would be.
Okay, so I feel like length field might be helpful, so I will prepare a pull request for that, and then maybe if there's more to discuss, we can do it in the issue or in the pull request. Then we can continue with the next mixing streams and datagrams. Bernard also brought this one up earlier in the presentation. The current draft only allows to choose between either streams or datagrams, but does not allow mixing both of them in one RTP stream. We mostly did that because we were not sure about what the implications would be and if there would be any possible downsides. But of course, there are some potential use cases for this, which were also brought up at the meeting in Philadelphia. For example, you might want to send iframes in streams and pframes in datagrams, or do scalable video coding based on streams and datagrams and put different layers in streams or in datagrams. One issue I hit when I was experimenting with this is that there was a synchronization issue, which is of course solvable, but the problem there was that I prioritized datagrams, and that led to the situation where the first iframe was received after the first datagram, and then I kind of had to wait for the first keyframe to arrive, but that is of course solvable in using a jitter buffer. So we're more like asking about this because we're not sure what are the other pros and cons of this, and we would like to hear the working group's opinion on this. Jonathan.
Yeah, I mean, obviously the needing to wait for the iframe after the pframe could happen just, because of partial reliability, because of separate reliability of the streams anyway. Even if they're on a stream, they're separate streams, you could have a packet loss on the iframe and thus it'll come in later. So I think this doesn't introduce that issue, it just maybe makes it more common. So I guess one question, which I'm not sure which way it pushes the answer, but it's an interesting question, is there was a question raised on the Zulip about whether there is actually a substantive difference between using datagrams and using less than MTU streams. And I guess there's probably detail differences in terms of how it appears on the wire, and obviously there might be implementation difference in prioritization, but is there actually like a fundamental difference between the two? And if there isn't, it might mean that mixing datagrams is fine, or it might mean we don't need datagrams at all. I'm not sure, but do you have any input on that?
So to understand correctly, the question is if there's a difference between sending frames on streams and sending frames on datagrams.
Well, specifically sending a, is there a difference between a data, sending something on a datagram and sending it on a single MTU stream?
Okay. Yeah, I think I get it.
In terms of the yeah, it's because it goes in one packet either way.
So I think there may be small differences in the handling of datagrams and stream frames in Quick, but the most obvious difference would be, I think, is if you have large frames, like large iframes, like Bernard talked about earlier, then that would.
Yeah. I mean, obviously, if it doesn't fit in one datagram, there's going to be a difference.
Yeah, I think that's the most.
But I mean, I guess in terms of like as the person not as the stack implementation, but as the person consuming the data, are you going to see like substantially different like network characteristics? And if the answer is no, I think then that means that A, mixing them is fine, but B, I'm not sure how useful datagrams are in any case, as opposed to just choosing to packetize some things not as a frame per stream, but as maybe multiple frames per stream over several RTP packets, targeting the MTU. You'd have to know the MTU, which is not always the easiest thing in the world, but but I guess you need to know that for datagrams anyway.
Yeah, so I'm not sure if there's a difference in how it looks like for the receiver. I would still think it's useful to have datagrams for less important things.
I guess my point is that if that is the case, that those aren't different, that also might mean that mixing them is fine because it doesn't introduce any new complexities. It only might make certain complexities more common, but they're things that are going to happen anyway.
Yeah. Okay. Peter?
I think on the receiver side, there's really no difference here. If you can receive frames and datagrams, you don't care which the sender uses. So I'm totally in favor of mixing. There are, like we talked about, some differences on the sender side of the size of the frame and the reliability mechanism you want, but on the receiver side, it shouldn't matter. So I think we should be in a world where if the receiver can receive either, the sender can pick either and mix and match.
Yeah, I think that makes sense. Bernard?
Yeah, I tend to agree with what Peter said. I mean, just because I didn't implement a jitter buffer doesn't mean I don't think it's necessary. And if you go and do that, then you should be able to handle either one of them. With respect to what Jonathan said, what I was seeing is that the stream per frame transport plus the partial reliability gives you something very close to datagrams. I'll reserve judgment as to whether it's almost identical, but you get a lot of, assuming the reset and other issues get cleared up, I think you should get able to get pretty close to the datagram performance.
Okay, I think most of the answers were pro mixing, and I think I would prepare a pull request for that, but I would still like to encourage everyone to think about any cons that you see with this. I mean, there may be some that we haven't thought of yet. That's why we didn't put it in there in the beginning, but otherwise I think it makes sense to go with mixing them. And I think that was the last issue I have to present. Yeah, we have next steps, resolve the open issues, obviously. Then I plan to submit a new draft and continue working with Spencer on SDP signaling. And I think that's it for today. Thanks.
Peter?
Yeah, I kind of had a question or two. I'm a little late to the party, and I have just read the drafts recently. But I guess there's a question for everybody. Does anybody else think it's kind of silly to just be stuffing an RTP packet as is in Quick and not take the opportunity to like change the packet format to not be as old and crusty as it is? Is that just me?
We went back and forth on this, and I think it's the certainly a lot of RTCP is possibly unnecessary, but a lot of the issues are you might need to interop with have quick over UDP versus quick over RTP over UDP versus RTP over quick interop, which implies, and then also just the issues of do you want to redefine 30 years worth of work we've done. And certainly a lot of features of this can be dropped. Jorg might have more to say to this because he's done more of the work researching that, so I'll let him talk.
Interesting. I need to grant browser permissions every single time. Okay. Yeah, I mean, we are effectively just sticking RTP packets into quick datagrams, right? The main question is whether we can actually get more accurate and more fine-grained information that we would compare to what we would usually obtain from our TCP, and we try to optimize only on that part. And that's not even mandatory, so we try to retain as much simplicity and potential backwards compatibility as possible.
Yeah, it's. I think we'll need to think a little bit more about the translation aspects, because it seems to me like it's a one-way door. That going from RTP over UDP to RTP over quick is not hard in a translator, but going the other way may be difficult or impossible. And that also applies if you start adding things like S-frame in there, where you have a translator really can't do the right thing because it's opaque. So it does lead me to wonder whether RTP over quick is a separate animal or not. Like I said, supporting the legacy really does help you go from RTP over UDP to RTP over quick, but the other way, I don't know. I think there's probably some more stuff to talk about.
Yeah, on the question of interop, I think Bernard's right that if you're sending with small RTP packets, perhaps you can translate over to a non-quick over RTP endpoint. But if you're sending big RTP packets, like one RTP packet, one sequence number per frame per quick stream, like how do you forward that to a non-quick over RTP endpoint? I don't know how that translation would work, because then you'd have to break that thing up, and there's no way to do that if you have the one sequence number.
I mean, and Peter, the thing that the middle box would have to know the packetization for every format that it forwards, right? And if it's S-frame encapsulated, then it can't even see it. So I don't know how that would work at all unless you have generic encapsulation.
Right. That's kind of what I was getting at, is if we're already going to do this big RTP thing, one frame per sequence number, then there's not necessarily a great interop story there anyway. And at that point, you can perhaps redefine what a big RTP frame means. As far as redefining 30 years of work, I'm pretty familiar with the part that WebRTC uses, at least, and I could fairly easily define a structure and say, okay, anything that can serialize this can be used to translate with RTP modulo the big RTP sequence number thing. And then you could say, okay, you could do it with protocol buffers, you could do it with whatever serialization format you want, kind of thing. And so I'd be willing to do that work, but the question is if anyone else is interested in that kind of thing, where we take this opportunity to redefine 30 years of work in terms of a nice, clean way that you can specify the fields in a frame of RTP instead of the current packetization system we have.
Yeah, I mean, I think just to the point of the gatewaying to RTP over UDP thing, I think we could conceivably come up with some like way of signaling to everybody, hey, here's an MTU to respect. But I guess the important question is, does anybody actually want to do that? Is we've all sort of had it theoretically, but is that actually needed? I think in terms of the new framing, I think it's an interesting idea. As an both as an individual and a chair, if you wanted to like do a quick and dirty, cut straw man draft, I'd be interested in seeing it. I don't know if that's, I'm not saying it's necessarily we'd want it, but it'd be worth seeing. I think, if we started getting a straw man, we could see, okay, how much work does this really be? Is it just, particularly the question is, how much of RTCP do you need? The RTP parts are pretty straightforward. It's not clear to me how much of RTCP you actually need, which is part of the question. Sergio?
Yep. For me, the complexity is just because trying to use quick streams. I mean, just replacing the TLS with quick and using RTP and RTCP seems something very easy to define and use. Not sure if it is worthy or not, but I think that most of the complexity comes trying to use quick streams that makes us have to define how the frame got packetized into a single quick stream. Then we have to define how to interrupt between quick streams, RTP over quick streams with the normal RTP. So that's why I'm a bit concerned about naming it RTP over quick at all, because I think that it is so different that normal RTP that I mean, for me, if I'm going to implement a gateway that is receiving this RTP 1 frame per RTP packet over the quick stream and send it to over normal RTP, it will take the same amount of time that implementing any other protocol like SRT or whatever, because I will have to depacketize. And so for me, the quick over streams, RTP over quick streams, maybe it's worthy, but I don't think that it is RTP at all.
Spencer?
I just wanted to add, we've talked about the gateway thing before, and what I was trying to sell at IETF 114 was basically deferring work on things that start to bleed into the topology RFC until we're a little further down the road. I thought there was some resonance in the room when, and I wasn't the only person saying this, but and it's fine to change our minds, even if we're leaning that way once. But like I said, just to recognize, once we start saying we're gonna worry about topology, it seems like to me that's a significantly large amount of work that if you didn't have to do it at the same time as you were doing the first specification, maybe that would be helpful for us. And I fully expect people to need us to do the topology work. The question is just how quickly they need that, and whether they can wait for it. Thanks.
Stefan here. Stefan being right. I think Peter's question is a good one, but it's not a good one for an breakout meeting here, where this it really should go to above. Frankly, this is really a big thing, yeah. And I would not be in favor, obviously, to kill work that's at least halfway, probably 2/3 way to its goal, in favor of a proposal that's pretty darn close to boil the ocean. So I would suggest that this debate ought to be held in a different venue and in a much broader scope, and assuming a much longer time frame than we have currently. Thank you.
Yeah, that's fair to say. We might want to do something better longer term, but we want to get this draft done shorter term. I would like to think, though, about how we could make this forward compatible, perhaps with something we might want to do further down. But I can think about that offline and come back, as Jonathan said, with a straw man draft. I do appreciate your concern, though, that if it tries to boil the ocean, perhaps it ought to go somewhere else. But I was trying to think of something we could do that would be better, but not try and boil the ocean.
And we should probably close the queue because we do want to get on to the next item before too long. But Bernard?
Yeah, I wanted to reply to Spencer about the topology issues. Basically, my perspective is that the topology issues, many of them are quite difficult and may not be easily solved, but this draft doesn't have to solve them. It can just note that they're out there, and for example, the issue of requiring codec-specific knowledge in a translator or the SRAM stuff, it can just write down the issues and say, hey, here's some stuff. So I don't think we necessarily have to solve them, but I think it is useful to be aware of them. Because I think, as I said, the interop is going to be limited, really, to going from RDP over UDP to RDP over quick, and the other way may be pretty difficult or impossible. So just say it and don't necessarily try to fix it.
Yeah, so I guess on the 2 points on the topology, I mean, obviously you don't need to solve the topology issues, but you also don't want to paint yourself into a corner, and with a solution that makes topology issues very hard to solve. So we need to be at least somewhat aware of them. And the other point, I guess, to the future thing going forward is mock is a working group now. It's just getting started. It's not solving exactly this use case, and it's pretty close. And maybe working there to make sure that whatever they define works or can be easily adapted for the RTP type use cases is a better thing than starting from RTP. Spencer?
And just following up on what Jonathan just said there, mock has been chartered, and it would be good for people to look at the mock charter and see if what we're talking about fits there. If it does, that's perfect. If it doesn't, if you want to do something like a BOF at IETF-116, it would be good to have a side meeting or something like that in the IETF-115 timeframe, just so we're not, coming up on 116 and saying, are we going to do anything? So I'm just suggesting having a side meeting for that if people are interested. And asking if people are interested in a side meeting might tell you something too.
Peter, since you raised the question, you can have the last word, and then we'll move on to green metadata. Or no, you don't have anything to say. In that case, we can move on to green metadata.
I forgot to take my hand down. I don't have anything more.
Okay, great. Go ahead. Thank you.
All right, thank you. Can everyone hear me?
Yes.
Okay, good. Thanks.
Yes.
So this is a quick recap of the RTCP message for the green metadata. Next slide, please. All right. So green metadata, or the energy efficient media consumption, is an ISO IEC standard developed by the MPEG. It specifies a set of metadata to reduce the decoder and the display power consumption. And one metadata is the interactive metadata for the decoder power reduction that is need to be specified to carry this data from the decoder to the encoder, or from the receiver to the sender. And we have the updated draft version, the 0.1 version, uploaded in July. And the draft specify a new RTCP payload format for the spatial and temporal resolution request and notification feedback message. Next, please. So we're following the AVPF RFC design style. The AVPF specified 7 payload feedback messages and 1 application layer feedback messages. So this document specified 2 new payload specific feedback messages, and the messages can be sent in regular full compound RTCP packet or in an early RTCP package. The following 2 figures are the detailed format for the request and notification messages. So it carried the picture width, picture height, and frame rate to indicate the spatial or temporal resolution information. So next slide, please. So thanks for Johnson's comment on the email reflector. We made the following changes. First is we assigned the new FMT value 11 and 12 to the request and the notification message, because the original value 9 and 7 were already assigned to ROI and LRR. And second change is the semantic update to prohibit the value of 0 for the spatial resolution or the frame rate to be 0. Originally the 0 means there's no video, but there's other mechanism to enable that function. So we update the semantic to disallow this kind of value. And third change is there's a redundant text description for the existing FMT value assignment, so that part is removed. And the last change is typos in green metadata reference URL and the email address. So those are being corrected. So those are the 4 changes in the revision 1. Yeah, next, please. So next step, we would like to ask for the WG adoption of the draft. So that concludes my presentation. Any comments, questions? Yes, Anna.
So what's the interaction with SVC?
Sorry?
So what is the interaction between this draft and scalable video codecs?
Scalable video encoders, yes. No, this is mainly about the green metadata, and that's applied to the general video codecs.
Well, the reason I ask is because scalable video codecs are carrying multiple resolutions in multiple layers, depending on each other. and thus requesting a specific resolution can be met in multiple ways, including turning off some layers and or changing the highest resolution. So I'm wondering whether you have actually looked at this.
Yeah, for scalable coding, if for the streaming, you can have different resolution presentation to choose. Or if for the real-time communication, if there is a SVC bitstream, you can adaptively change the resolution. If the bitstream you receive is not SVC, then you probably need some metadata format to request the resolution or frame rate change at the encoder side. And I think SVC is not deployed widely. So for some video conferencing or real-time video communication, there's still single layer bit streams exchange between the sender and the receiver. Yes.
Yeah, I mean, I think somewhat to answer Harold's question. I mean, the point of this is that this is the way that the receiver says, this is what I want to, this is the maximum thing that is, useful for me, or that I want us to get for power. And then what the encoder does to satisfy that, is up to the encoder, and thus the encoder can choose, hey, I can turn off a layer, or I can change the top resolution, or whatever, and those could all be valid choices, but that's a choice. So I think it might be worth having a little bit of discussion of that, but just clarifying that, but I think it's not necessarily doesn't necessarily need to be firmly specified what exactly it means in this context. So yeah, speaking as a chair, I think we can certainly do. Or sorry, Srinivas, did you have a comment? Go ahead.
So just I would like to add, actually, thanks Young for the presentation, and definitely these kind of RTCP feedback messages are important to reduce the power consumption at the decoder side. So we actually thought maybe we also support kind of messages, but understanding that a few changes can be added in the near future. So I'd like to basically notify that maybe we will be presenting few more updates to this in the near future, so that we can still present the updates in the near future. Just wanted.
Would you want to do that? Okay. Would you want to do that after workgroup adoption or before? That's an important.
Probably we will try to come up with some updates before for the next meeting. So I'm not really sure on the adoption process, but yeah, but we support this.
Yeah, I mean, if this is additional functionality beyond what the core, beyond basically doing different kinds of doing different kinds of messages, I would be inclined to say that should be in the thing the group is considering for adoption. But if other people have different opinions, I could let them talk. Stefan?
Yeah, I mean, yeah.
So allow me to help you with this.
Sure.
Stefan Wenger here. I'm following this from a distance in MPEG, and I'm also following this from a distance here. So no, we don't have to wait. There's the right so just generally speaking, the screen metadata stuff, that's in a stage where it's being fine-tuned in MPEG, but it's not that there is anything earth-shattering coming out in the foreseeable future. So from a viewpoint of an RTP payload format, I doubt that a lot will change, except maybe in the signaling and maybe, you know, small stuff.
Well, I mean,
no.
I guess the
So
question is, I
if
know that there were, sorry, I know
Yeah,
that
go
there
ahead.
were something like four different messages in the MPEG document that I got forwarded, whereas this only includes one of them, which is the resolution frame rate one. So my question is, would you want to include others of those core messages as well, or just, that's the important question, I think, for the, let's try to go to that question.
That's not for me to answer.
Go ahead.
That's for them.
Yeah, exactly. That's what
So,
I'm going to ask.
So we just wanted to make sure that even if we do that option, it should be possible for us to add a few more details, more messages. That's what I would like to check with you guys, so that if it is possible, we are okay with that. Otherwise, we can present them as early as possible, so that we can, and the group can take a decision on that.
I mean, the other possibility, of course, is that these don't all have to be in the same document. If you have additional feedback messages for different green metadata, it might be worth breaking them out into a different document if they're doing something different. I don't know if this is all addressing one MPEG spec, maybe it should all be in one feedback, but if they are doing fundamentally different things, like one is requesting rate and picture width, and the other is requesting more like low-level details of the display or what the display or the encoder is doing, that might be interesting. That might be separable.
Question is it can we do it in the same document, even if we get
you can. I mean, I guess the question is, and if there's nothing wrong with doing the same document, I guess I just feel like if you're adding additional feedback messages beyond temporal spatial resolution,
Jonathan, they are not. This is not going to be. They are not going to boil the ocean. They are not going to do anything.
Okay. Yeah, I mean, if this is just going to be, if this, yeah.
The basic mechanisms of the payload format. I mean, what we could do is perhaps just don't adopt it now. The timing is such that the Mainz meeting of AMPEC is just before the IETF over in London. So let them go through the Mainz meeting again, and then we revisit it in the main session over there. That's probably the right thing to do. But you can also just
okay. I mean, basically, yeah. I mean, I think.
Yeah.
I mean, the document as it is ready for adoption with this functionality. I think the question is, would you want to add further an additional feedback message beyond the temporal spatial resolution, or is this just minor enhancements to this? That's the question I have.
Yeah, I think we probably prefer to add in new messages. Yeah. But yeah, I mean, similar, of course, it's for the power reduction, but like,
yeah,
a new messages probably mostly.
So what is the action item for this? Are we going to wait for a new draft and then do a call for adoption, or what exactly is the next step?
I would be inclined to say if you're adding an additional message beyond this one, I would be inclined to let's see that in a new draft before we do the call for adoption. Personally.
Yeah, just clarification. Yeah, we don't plan to add anything new, and we discussed that before. I think the other messages probably not implementable. So, but yeah, if Srinivas,
I mean, alternately, if there's Srinivas wants to have another message and Younghae does not, then maybe Srinivas should submit a separate draft for the other message, and we can consider them separately. That might be better then.
Mm-hmm.
In which case, we could do a call for adoption on this document. So yeah, I mean, if you want, Young, if you want to just do a call for adoption on this document with the functionality it has now, then let's do that. I think that model is the best.
Okay, that sounds good.
Okay. And Srinivas, if you want to add another, if you want to have additional messages, I'd suggest add, or write a separate document and we consider that separately.
Sure. Thank you.
Okay.
Okay. So I think that is it for the agenda.
Yes. So I think.
Is there anything else?
So we decided just to finish up on that. We decided we are going to do a call for adoption on the green metadata document as it is now.
As it is now. Okay.
Please. Yeah.
Please put that in the notes.
Yeah.
Are there any other action items or next steps that we should note for the minutes? I guess not. So I think we're done for the day. Do you agree, Jonathan?
I agree. Thank you all, and we will see you in London or on a virtual stream with some of us in London.
Thanks, everybody.
Thank you.
Bye bye, everyone.